Well, good morning, everyone, and welcome to this webinar or meeting. It will be about plant nutrition, Næring plantna. And if we could look at next slide, Pius. I will explain a little bit about our program today. We will go over in this webinar, maybe start with our goal. Our goal, both for VG and Plant Health Cure, is to educate people on sustainable growing methods for all growers, big farmers and small. And the topic of today is plant nutrition. It will be about 20 minutes presentation by Pius Floris. Then we will have a little discussion, plus minus 5 minutes. Then a little introduction about organic plant food by Pius also. Then we will talk a little bit about upcoming webinars that we will be keeping. This meeting is recorded. It will be contacted in English, and you can ask questions in Icelandic later on. So I need to admit everybody into the meeting. So Pius, go take the space.
Thank you very much, Hjörtur, and welcome to all. I don't see many participants, but I only have a few people on screen. Well, very nice to meet you here. Yes, we will be talking on plant nutrition, and I would like to ask everybody to please mute your microphone. That helps in the sound, the quality of the sound. Thank you. It's about plant nutrition. We have a simple statement there. People and all living creatures on this world, they depend for 100% on the soil. So what if we depend on the soil and we only use chemical fertilizers? What would that mean to us? This is what I want to talk about. Yeah, it's what you see now, it's food, but is it nutritious? Is it good for our bodies? Is it good for our lives? Is it good for our health? Or does this type of food create all kinds of very silent inflammations in our body that what most people cope of the rest of their life? Yes, the hamburger provides enough minerals to make a person grow. Fertilizers, synthetic fertilizers, they provide the minerals to make plants grow. But do they stay healthy? And is it true that we need all the pesticides that we have in order to protect plants? There's an old saying, plant eats stones. And the soil is the external stomach, the external intestines. So the plants have their stomach on the outside the roots. It's in the soil, basically. And except carbon, water, nitrogen, and oxygen, everything else from plants comes from the soil, which all originates from rocks. And do plants eat rocks really? This is how we have learned all of our lives to see absorption of plant minerals. And it's much more complicated than that. And the first law of the minimum from Justus von Liebig, 1854, that's like 200 years old. It's not valid anymore. We know more, and plants are much more complex than the time that most of the laws around fertilizing, around plant physiology are written. So this is not how it works. How it does work, I will explain you in the coming period. This is what we call the von Liebig's law of the minimum. You cannot put more in the barrel than your lowest part of the segments, which is really important. And that's why we overfeed our plants with many minerals in order to get some into the plant. And like I said, this is 160 years old, the law of the minimum from Justus von Liebig. This is an old graph, and if you look very good at the picture, you will see today it's a museum. And you can see the wood stove on the right hand, which represents the experiments that Justus von Liebig did by burning plants and analyzing the elements in these plants, so he could say what deficiency that plant would have. Is it manganese or iron? Or so he did very valuable work. But he, at the end of his life, he wrote literally, I made a few mistakes because I realized that plants cannot live on minerals only. So, but we forgot about that. And we sort of turned crazy, all of us, because basically after the Second World War, we started working with kalium. A huge amount of kalium is being applied in agriculture. But if you look at kalium, it's right there. It's on the very left column of the periodic table, and it's number 19, and it's right under sodium chloride. It's a salt. It's a sister of kitchen salt. And we shouldn't raise our plants with a lot of salt. I was told not to eat too much salt, but we feed it to our plants in big amounts. And I really want to emphasize on this. Kalium chloride is what we mine. It's a mining product, and it's applied to plants. It is not potassium. People call it potassium in the whole world. It's not. Potassium was meant by the Romans, literally the ashes from wood fires. And see what happens, and I will come back to the wood fires. See what happens if you put a brick in pure kalium. After 6 months, the brick looks like this. It's being dissolved by the kalium. Sorry, and that means a lot. That means that the amount of kalium also ruins the soil structure, because the soil particles, especially in clay, they become smaller and smaller and smaller, causing compaction, causing loss of oxygen, causing many other problems, not only for the plant, but also for the soil. Do plants need the 16 or 17 elements that are required in fertilizing schemes? That's funny, because when you analyze the first single plant, you will have at least 30 elements. But we only analyze on the fertilizing part. When I come back to the potassium or potash, it was literally meant for the ashes from wood fires. And this was how every bakery in the world would bake their bread, on wood fire. Until we had other sources, every baker would bake his bread on wood fires. In the Netherlands, that lasted until the early 70s of last century, when we had natural gas under the Netherlands. That's when it changed. But before that, it was wood that was burned. And you see that bin under the wood fire, that was to collect the ashes. And the handles were for the ash collectors, they would pick up the ashes and bring it to the potash factory. And they made soap out of it and agricultural fertilizer. But you can imagine in that ash, all minerals that the tree that was burned absorbed from the ground during its lifetime, that ash had the presence of all these minerals. And you see some of these minerals on the right-hand side. Some are known, others are unknown, but they were absorbed by plants anyway. And what do they actually do? And yes, ashes from wood contain a high amount of kalium. Even in forests where not a single person ever entered, you have kalium in the trees. That means there is kalium in the soil. And many, many minerals in the soil and stone formations, they have a lot of kalium, a lot. And normally it's 19%, but kalium is hidden in minerals. I don't want to go too deep in that, but roots cannot absorb kalium from the soil. The mycorrhizal fungi, and we will put another presentation on mycorrhizae and their role, but the mycorrhizal fungi, they can eat away the kalium from the other minerals, which is very important because kalium is the 7th most abundant mineral on Earth. There is no kalium deficiency in this world. There is a problem with absorbing kalium from the soil, but that's a different story. And many, many old research is already shown when you bring wood ash on your land, it will certainly help your grasses and your feedstock to perform better. When we talk about rare earth elements, they really play a big role in healthy plant growth. And if we ever think about new fertilizing concepts, these rare earth elements, they should have a role there. If we look at people, a lot of research is done on people and animals, a lot more than on plants. But if you think about it, and I already said it, all living creatures on this world, that includes animals and people, they live from the soil. So all the elements in our body actually came from plants or animals that ate plants and passed on their minerals to us. And you see there is like less than 1% non-essential elements in all of our bodies. But I'm the least one to say they're not important, because they are really important in creating metabolites in our bodies. And the same goes for plants. There's less than 1% non-essential elements in plants. But how non-essential are they? Are they non-essential for growth? Fine. But maybe they're very essential for plant health, because plants do absorb these minerals. I sort of compared it with my car, and the fuse box in my car is less than 1% of the total, a lot less. And if you look at the role of that fuse box, it prevents fire, it prevents infections, it prevents constant inflammations. Oh yeah, you can solve that with a nail or with aluminum foil. You can solve the broken fuses. But at the end of the day, your car will burn totally. That's literally an inflammation. And this is exactly what happens with people and with plants. And there is so much literature going on in this world on these topics. We don't get the minerals in our bodies that we really require. And I think that is one of the biggest problems that we face for our animals, for our sheep and cows and people. We don't feed them properly. And I think we could do a lot better job there. And also for organic farming, it has a difference. It has a difference with the synthetic farming, because you make your plants more depend on the soil quality. And I think we have to learn to look at soil quality in a different way. Also here, this picture, this is common literature. It's not mine. I didn't invent all of this. It's there on the internet. It's live. The information is accessible for everybody. But Wikimedia Commons says at least 15 elements in our bodies count for less than 1% of the total. And this is exactly what I'm talking about. I guess this is a time for questions. I don't know. I don't know what it means.
You're quite right, Pius. You're getting to know Icelandic quite a bit.
Yeah, the Q&A I can read.
Yeah. So now it's a little time for questions and answers. Maybe if somebody has something, you can use the chat box here, or unmute you and talk in Icelandic. Someone? One of the Icelandic ladies I was talking to, Eygló, she said that to your presentations, Pius, that you are always so clear and make people understand. And I think that people understand quite well what you're saying.
I take that as a compliment. Thank you.
Yeah. But your main message is how do we get all the other minerals into the plants? That is the main task that we need to think about.
Yes.
Yeah. From Signy in the chat, is permaculture a good answer to soil problems?
Any culture that doesn't destroy the soil but builds up the soil, any culture that allows plants to feed the soil is a good one. Chemical fertilizers are not on the list for healthy plants. So any chemical fertilizer will by definition undernourish your plants. And if you undernourish your plants, you will undernourish your animals. And if you eat these animals, you will undernourish yourself. So we have to rethink that whole model of nourishment. We need more than 17 elements that we talk about. And there's a lot of literature coming out this way.
Good. Any other questions? Yeah, there's one. Do you recommend to put ash in our vegetable, where we grow our vegetable?
You mean wood ash?
Yeah.
Yeah, but not too much.
Not too much.
Like a few kilos per year per hectare would be fine. The thing is, we don't know what we don't know. We cannot analyze on these micronutrients that should be or could be present in the plants. We know about details, like in the past years, selenium became a topic. If you now look at cerium and lanthanum, they become research topics. Not as a whole. Oh, not as a whole, but the researchers, they look at the individual elements. They don't really look at the whole system, but more at elements. That's up to the need to fulfill to the statistic roles that we have in science. So they can only look at one thing at a time.
Okay, Thráin is asking, what is your opinion on biochar? Biochar.
Biochar, it's carbon, and it's a solid solid carbon, and carbon is a food for every creature on this world. So yes, biochar is a way of adding carbon to the soil. Personally, I think it's an overrated system, because people look more at the carbon than at the total complexity of the soil and soil life. Yeah, but biochar, the terra preta idea is it's from old Indians, etc. It's being accepted. It's nice, and it's great. Any form of carbon is carbon. Put it in the soil, unless it's crude oil.
Mm-hmm. Good.
Sometimes I think I make a joke, but I see nobody laughing.
It's a problem with these webinars. So it's very difficult, especially for comedians, to give performance on the webinars. Yeah,
true.
But we are learning to live with this. Any more questions? Yes. Sigrún Oddgeirsdóttir asks, what is good to use in combination with ashes to improve the soil?
Well, you live on Iceland. You have a volcanic island. So basically, I couldn't say how much minerals you would need to add. But if you have ashes, you play for sure. You play on security. You have more minerals on your island than organic matter. So the focus is to create organic matter, fertilize organically, and make use of the soil biota, the microbes, the fungi, to make sure that your plants will absorb all these essential minerals. That would be my answer.
Okay, very good. Guðni Wahlberg, what is your opinion on using human manure as compost? Is that something people should do? I have seen it done with permaculture with warmer countries like Australia.
Well, we used to do it, but then we got cities and sewers, but I visited China a couple of times, and I was really welcomed to do what I needed to do in the field, because the human consumption of food is the only missing link, basically, in the whole recycling system of minerals. What we shit out is being destroyed instead of being used.
Good. Maybe one last question, if there is somebody with, and we were going to have this short, only 30 minutes, and I don't see any questions, so we proceed to talk about one of the product line, Pius, that we are offering, and then tell you all about upcoming webinars.
Yeah, well, we deliver already many years organic plant food. It's made from plants, it's for plants. This product contains the amino acids that you can that are being transferred into plant food. Plants grow from that, and the better nourishment you put on a plant, the more exudates or root exudates the plants will produce. So basically, if you talk about organic plant food, we're not complete. Every fertilizer has to feed both the soil and the plant. If you only feed the plant, you will take energy from the soil. Organic plant feed we measure the level of energy in organic plant feed in our products, and it has a high level of energy. So it is also food for the soil. We have that both in a granular and in a liquid formulation. We have the trace elements, amino acids, also plant-based, carbohydrates, sugars, and 7,000 megajoule per kilogram of the product energy. If you look at energy and you take the how do you call it, the power drinks, the caffeine power drinks, like I forgot the names.
Bull or Monster or something.
Yeah, Red Bull. Yeah, thank you. Red Bull, Monster. They have an energy level of 2,000 megajoule per liter. And our fertilizer is 7,000 megajoule per kilogram. That's a lot more. We have a lot. We have heaps of researches. This is from the soil service in Belgium, where OPF, the green one in this picture, had the most fluent absorption rates and was basically most efficient in both nitrogen and the rest of the output. So it is a very stable and long availability, and the beauty of organic plant feed versus most other, even including the animal nitrogen, it doesn't leach out. It binds itself to the soil particles. It does not leach out. And well, we've been doing trials and trials even this year again. And if you see the differences in synthetic and organic, we can really say that organic, if you're a good organic farmer, you produce more per hectare than conventional farming. Because conventional farming requires spraying with chemicals. And if you spray with chemicals, and we have proven this over and over again, you will lose, after every spraying, you will lose 2 days of plant growth, because the plant will not grow during this recovery period. It needs all its energy to overcome the pesticide problem that they are faced with. But we never looked at the plants, we only looked at the diseases, and that's a real big problem. So, my time is over. Up to you, Hjörtur.
Yes, thank you, Pius. Very interesting presentations and answer to those questions. We have planned to have maybe 5 or 6 or 7 more of meetings like this in the coming weeks. So here are some examples of what we are thinking about. You have to push it forward, Pius. Next, we think we are going to talk about diseases, plant diseases, how to avoid them on 10th of November. The next one will be trees from A to Ö or Z, both in the nursery and growing them in the field. Next one, agriculture in general, so potatoes, cauliflower, etc., and how you should think about your soil. Next one, binding of carbon, which has been really talked a lot about in the world, basically. So we will see how we can help solve that problem. Plant nutrition, plant næring, foliar feeding, we will talk about in January. Then we are thinking of talking about trends in the environmental legislation. Pius is an influential man in that area in Brussels, I think. I don't know if I'm exaggerating, Pius, but you know a lot about this and could maybe share your knowledge about about the trends that are happening in Europe and the rest of the world. Okay. Next one. Just to remind you of our websites for more information. Next one, Pius. Your website, which is an excellent resource of information in 3 languages. And with that, I would like to close this session and thank you all. Thank you especially, Pius, for your presentation. Thank you for participation and putting forward your questions. Follow us on Facebook and we hope to see you in our next meetings. Thank you. Bye-bye.
Thank you very much, all of you.
Thank you. Thank you.
Thank you very much.